Before anything we know, before time, before space, there was nothing. Not darkness, because darkness needs space to exist. Not silence, because sound needs time. This was true nothing. And yet from that nothing, everything began. About 13.8 billion years ago, what we call the Big Bang happened. But this wasn't an explosion in space, because there was no space. The Big Bang was the moment space itself, and time itself began to exist and expand. Everything in the universe was compressed into an incredibly tiny, hot, and dense state. So where did the Big Bang happen? The answer is strange, everywhere, because the entire universe was that point. And when it began to expand, it expanded in all directions, everywhere at once. That's why scientists can't point to a location and say, it happened there. We are inside the universe, while it is still expanding. Like dots on the surface of a balloon being inflated, no dot is the center, because the surface itself is stretching. In the very first moments, the universe was unimaginably hot, so hot that atoms couldn't exist. Matter, as we know it, didn't exist. There was only pure energy. But as the universe expanded, it began to cool, and something incredible happened. That energy turned into the smallest possible building blocks of reality, fundamental particles, tiny pieces that cannot be broken down any further. Particles like quarks, which later formed protons and neutrons, and electrons, which would eventually orbit atoms. These were the first building blocks of everything. But something else was already shaping the universe: gravity. And here's the surprising part: there were no stars, no planets, nothing massive yet. So where did gravity come from? Even energy can bend space. In the early universe, that enormous amount of energy caused space itself to curve. And when space is curved, things begin to move toward each other. That's what we experience as gravity. Because of this and other fundamental forces, these tiny particles began to come together. Quarks combined, forming protons and neutrons. And within just a few minutes, the first atomic nuclei were born. Hydrogen and a small amount of helium, the first elements in the universe. Nothing more complex could form yet, because the universe was still too hot and there wasn't enough time. But everything that would ever exist started here. Then, hundreds of millions of years passed. The universe became dark. No stars, no light, just vast clouds of hydrogen, floating in silence, until gravity began to take over. Slowly, these clouds pulled themselves together, becoming denser and hotter, until deep in their cores, something ignited: nuclear fusion. Hydrogen atoms began to combine, releasing enormous energy, and in that moment, the first stars were born, the first lights in a once completely dark universe. These stars didn't just shine, they became cosmic factories. Inside them, new elements were created, elements like oxygen, the very element that would one day combine with hydrogen to form water. But that part of the story comes with the death of stars. But for these elements to be released, something extraordinary had to happen. Stars had to die. When massive stars reach the end of their lives, they collapse and then explode in events known as supernovae. In these explosions, everything created inside the star is thrown into space. Oxygen, carbon, and many other elements scattered across the universe. For millions, even billions of years, these elements travel through space, inside vast clouds of gas, or locked within comets and asteroids, waiting for the right place. About 4.5 billion years ago, a new star was born, our Sun, and around it, dust and gas began to come together, colliding, sticking, growing, forming planets. One of those planets was Earth. But early Earth was nothing like the world we know today. It was violent, hot, and unstable, a surface of molten rock, constant impacts, and conditions far too extreme for life. At first, Earth had almost no atmosphere. Any gas that formed quickly escaped into space. But slowly, things began to change. The planet started to cool, heavy materials sank toward the center, while lighter ones rose toward the surface. And deep inside, Earth's core began to form. A core made mostly of iron and nickel, but more importantly, its outer layer remained liquid and in constant motion. This movement acted like a giant engine, generating something invisible, but absolutely crucial: Earth's magnetic field, a protective shield, defending the planet from solar winds. Powerful streams of particles coming from the sun. Without it, the atmosphere would slowly be stripped away. But where did Earth's water come from? Did it all arrive from space? The answer is, not entirely. Part of Earth's water did come from space. In the early days of the planet, icy asteroids and comets bombarded the surface. These objects carried large amounts of water in the form of ice, and with each impact, some of that water was delivered to Earth. But that's not the whole story. A significant portion of water came from within the Earth itself. The materials that formed the planet already contained water, and as the young Earth remained active, volcanoes released this water in the form of vapor. Over time, as the planet cooled, this vapor condensed. Clouds formed, and rain began to fall. And it didn't stop. For thousands, perhaps millions of years, rain poured onto the surface, filling valleys, covering the land, and forming the first oceans. So Earth's water is a combination of what arrived from space and what was released from within. But one question still remains. Why did the water stay? Why didn't it disappear, like on so many other planets? The answer lies in a delicate balance. Some planets are too hot, causing water to evaporate. Some are too small, unable to hold on to an atmosphere. And without an atmosphere, water escapes into space. Others lack a magnetic field, leaving them exposed to powerful solar winds that gradually strip everything away. But Earth had everything it needed: the right distance from the sun, the right size, a stable atmosphere, and a strong magnetic field that allowed water not only to arrive, but to remain for billions of years, and eventually to give rise to life. So every drop of water you see today, every ocean, every river, every drop of rain is ancient, born in stars, traveling across the universe, and finally becoming part of this world and part of you.